Okay, so this video is going to explain a little bit more about linear programming, and the way that we're going to do that is through this person named Nikki. So Nikki has two part-time jobs, jobs 1 and 2. Nikki is very particular, and we have some constraints for her. She never wants to work more than a total of 12 hours a week. So she doesn't want to work more than 12. She can work 1, she can work 10. It doesn't matter, just as long as she reaches that 12, she's fine. She has determined that for every hour she works at job 1, she needs to prep, and she needs 2 hours of prep time. And for the other one, she only needs 1 hour. Because there's so much prep time, though, in between the two jobs, she says this: I cannot spend more than 16 hours of prep. And then here's the pay. Nikki gets paid 40 an hour at job 1, while job 2, she gets paid 30. And so our job is to figure out, well, if she wants to work a total of 12 hours, what is the balance between the two so that she gets the most amount of money instead of overworking herself? So I think whenever it comes to these problems, we need to just first establish the equations. What in the world is going on? I think rating sentence by sentence helps. So I'm going to look at the first one. She never wants to work a total of 12 hours a week. So this is about her work hours. So I'm going to write that as one equation. Well, we have two choices between job 1 and job 2. So we can let job 1 be x, and we can let y be job 2. And so from this, we can say that x plus y should be less than or equal to 12. It can be less than 12. She can work 10 hours, but she just wants to work a maximum of 12. Then we look at the next part, and this is going to be the prep time. So I'm going to write for the second equation, it has to do something with prep time. To this, she says that for job 1, so that's x, she needs 2 hours each time. So we're going to say that that's going to be 2x. And then for the next one, she says only for job 2, I need 1 hour. So we're going to put 1y. This should be less than or equal to 16 because it clearly says in yellow, she cannot spend more than 16 hours of prep. Then we look at our final equation, which is our objective. So we're going to call it our objective. This is our goal. I'm going to write that as a quote. It's our goal. And the goal is the money earned. So how much does she earn? Job 1, she earns 40, so we can say 40x. While the second job is going to be 30y. She spends $30 at job, or she earns $30 an hour at job 2. We don't know what this equals to because we clearly don't know how much money she'll get just yet, but this is at least our 3 equations. And so from this, what we need to do is we need to figure out how to graph it. So the first step that we need to do is declare our equations. The second thing is we need to establish our graph. And so what we need to do is we need to graph these two things. So then all we need to do is just take this and then paste it, so that we can say there are 2 equations. How are we going to graph this? I'm just going to graph like here, kind of a XY graph, kind of like this. It doesn't have to be perfect. It just needs to just have a good representation of both. Whenever we start graphing, we need to consider some options. What are the extremes that we can have? Let's let x be job 1, and let's let y be part of job 2. And so if we're looking for x, we can see here for hours. Let's see, for hours, what is her options, her max options? Well, for job 1, she can work 12 hours. So we can say for hours, she can do 12 hours job 1, and then 0 for job 2. Or the opposite. So we can say 0 hours job 1, 12 hours job 2. And so we're going to mark that here in our graph. I'm going to do that in blue. So here in blue, that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here in blue, I'm just going to make a line symbolizing that that's going to be hours. Then we can consider the second equation, which is going to be the prep. So in this case, we can see here for prep time, she needs 2 hours every hour for job 1. Well, what we can do to find out how many hours that would be is, well, we can say 16 divided by 2. That would give us 8 hours. So she would need 8 hours to prep for job 1. So 8 hours for job 1, 0 for job 2. While the other extreme is, well, since she only needs 1 hour for prep time, that means the other one could be or 0 for job 1, but then the whole number of hours, which is job 2. And so we can look here, these become points. So if you kind of see in the first one, this had 12, while the y had 12, and this is from the established 12, 0, 0, 12. Same can be said here. This is going to be in yellow, 8, 0, or 0, 16. So I'm going to plot that. So here is going to be 8, and here is going to be the 16. And I'm just going to make a graph like this. Now we can see here, we have the point of intersection. We're going to find that soon. And we also see that for both cases, if we remember about anything about linear programming, that the area, this part right here, so all that I'm going to be like highlighting and all that stuff, this is what we call the feasibility region. Anything in this region will give us our answer. It satisfies both conditions that Nikki wants, and it'll give us our answer. So whatever's in there will give us our answer. We need to find our point of intersection, which is step 3. So I'm going to find the point of intersection. The way I do that is that I need to make these two equations equal to each other. So I have x plus y equaling to 12, while the other one is 2x plus y equals to 16. And I have to ask myself, how do I kill this? Notice that they're both positive y. I need to make one of them negative. So I can do this. I can make it negative x minus y equals negative 12. I made everything negative. While on the bottom, I get 2x plus y equals to 16. And now look, I have opposites. What happens? Y's cancel out. And I do that by adding. So I'm going to add negative 1 plus 2. That's 1x. Well, this one's going to become negative 12 plus 16, which is 4. Replacing 4 for x, we get this. 4 plus y equals to 12. I want to get rid of the 4, so I have to subtract both sides by 4, giving me the answer that y equals to 8. And so that's our point of intersection. This is 4, 8. So with that being said, how am I going to figure out which one will give me my max profit? This is the last and final step, which we call testing points. If you remember anything about linear programming, the red, the region that satisfies both lines, these 3 dots are usually the ways that we can confirm which one's the maximum. So in our case, we have the 3, 4, 8. This one, 8, 0, that we wrote in yellow, while the one in blue, we wrote 0, 12. So I'm going to write them again. 0, 12, 4, 8, or 8, 0. So all we need to do is just test it with profit, or the earning /earn. Plugging in this one, since she only works 12 hours in the second job, that's going to be saying 30 times 12. That's going to be 360. If I do the next one, she earns 40 for the first, so that's 40 times 4 plus 8 times 30, so 8 hours for the 30. When I get that, I believe I should get 400, because that's 240 plus 160. While the last one, I get 40 times 8, and only that because I only work that much, and I get 320. So clearly we have one answer out of the 3. That makes sense. We have 400. And so our answer to this is that Nikki should work 4 hours at job 1 and 8 hours at job 2. So that's kind of the flow for how this works. You interpret the problem by making equations. You graph based on the points you see. You kind of shade in the area that works underneath both. you circle the 3 dots, you figure out what the 3 dots are to then test it out and see which one gives you the highest point. But that's essentially today's video. Hope you guys enjoy it, and please let me know if you have any questions about it.